Hello everyone, welcome to this video. My name is Pushpinder Gill, and now let's go ahead and solve this question. So this question is a data sufficiency question we have the information here that if a does not equal to 0, so I'm just going to write it down here that a is not equal to 0, is 1 over a greater than a over b to the power 4 plus 3. Now there are two things that you have to be careful about here. The first of all, it's a yes/no data sufficiency question, right? So that means all the yes/no data sufficiency rules apply. For each of the statement, you have to find out whether you will always get a yes or you'll always get a no for it to be sufficient. If you get either a yes as well as an or at least a no for each of the statement, then that statement is insufficient. So that's important. The second is that you have an inequality here. And one of the rules of inequalities is that you cannot cross multiply variables unless you're sure that they're positive, right? So is there anything that I can do from this inequality before moving on to my statements? Well, at least I know that b to the power 4 plus 3 is positive, because anything raised to the power an even number is always positive, and plus 3 is always going to be positive. So at least I can easily take this to that side. That's what I can do, but it's not going to be of much help because I won't be able to take the a to the other side because I don't know if a is positive or not. So that's exactly what the first statement does, right? So again, it's very important to kind of dissect the body statement before you move on to the actual statements, because you are able to understand the question in a better way and you're able to use the statements in a better way. So the first statement here says that a is equal to b squared, which actually implies that a is a positive number, right? So a is a is a positive number, and definitely a is not equal to 0, right? So that is something that we've been told in the question stem, otherwise this question wouldn't make sense. So that means you're sure that a is a positive number. That means now you can cross multiply this inequality. So the inequality is that is 1 over a greater than a over b to the power 4 plus 3. Well, now you can easily cross multiply. So the question becomes, is b to the power 4 plus 3 greater than a times a, which is a square? And since a is equal to b square, that will actually imply that a square is b to the power 4. So I can just use this information and I can input this information here, right? So I'll get b to the power 4 plus 3. So is b to the power 4 plus 3 greater than a square, which is actually b to the power 4? So is this always true? Well, yes, it's always true, because if you eliminate b to the power 4 from both sides, the question actually becomes, is 3 greater than 0? Well, that is always true. So that means this statement is sufficient, right? So that means it's either answer option A or answer option D, right? So we're able to eliminate B, C, and E. All right, so moving on to the next one, which is a square is equal to b to the power 4. Now this is a little tricky because now here we are not really sure if a is a positive number. So that's the trick here, because you can have a to be a negative number. So for instance, you can have a to be 1 and b to be minus 1. It can still work out. Or you can have a to be 1 and b to be 1. It can still work out. So this statement just implies that a can be a negative number as well as a can be a positive number, right? So it can be both, which means I'm stuck with the body statement, right? So it means it doesn't really help me as much. But what I'm going to do is, just to disprove this statement, just to find out that this statement is not really sufficient, I have to do a little bit of algebra for me to go ahead and find out what's really happening. So what I'm going to do is I'm just going to substitute the value of substitute the value of a square is equal to b to the power 4 in the equation. So the equation is 1 over a greater than 1 over, so instead of b to the power 4, I'm going to say a square over 3, right? So that's the statement that we have. Now we have to find out whether that statement is always true, always false, or is it at least true in some cases and false in some cases, right? So that is something that I have to find out. right? So what I can do is I can, just simplify this equation. I can just take this to the other side because this is at least positive. So this becomes is a squared plus 3 over a greater than a. I can just further simplify it. I can, remove this left hand side. So I can say is a square over a. That actually becomes a square over a plus 3 over a greater than a. And then this is just going to eliminate 1a. So the question becomes is a plus 3 over a greater than a. So that's what it becomes. And now I can just eliminate the a on both sides, right? So I can just, take a to the other side, and that will just eliminate it. So the question becomes is 3 over a greater than 0, right? So that's the question. Now we are not sure because we have already told that a can be a positive number as well as a can be a negative number. For positive numbers, this is going to be true. For negative numbers, this is actually not going to be true because 3 over 1 is greater than 0, but 3 over negative 1 is not greater than 0. So that means that this statement is insufficient, right? Because it gives us two different values, like it gives us a yes and gives us a no. So that means answer option D is eliminated and A is the answer. So just a little takeaway from this question is that you have to make sure that you solve the inequality all the way till the end. Like, I mean, in the real test, you must be incentivized to just leave the statement to as it is and assume that it is insufficient. It actually turned out to be insufficient. However, a good idea is to solve it till the end so that you can actually simplify this equation to a very simple situation wherein you just need to identify whether it's always going to be true or it's always going to be false. So so that's what it is, guys. So thank you very much for watching this video. I'll see you in the next one.